Okay, cool. Okay, so in the previous class, we were looking at a couple of things. We are looking at the testing point of view. How do you load a web page? How do you test? How do you request for the page? How do you time the page? Whether there are certain elements in the page and all that. So we're going to continue on those lines regarding more testing. Okay, so yeah, so this is what we did last time. So we had we selected ebay.com and then we loaded the page and then we looked for certain elements in the page. But this is this is one of the way that you can test a web page. But there are many other ways. We're going to look at some other ways right now. So you can see that one of the things I did here is I'm looking for this text inside the response. Okay, so we got a response and we are looking for the response text saying, is there electronics and all this in the title? Is there a sign-in page in the web page and all that? Okay, so we're going to fine tune this a little better. So we're going to look at that in this session. Okay. And by the way, regarding the assignment, only 3 people submitted the assignment. I want everyone to submit that. So it's just for me to know that you guys are practicing. And also if I see any major issues with your code, I can probably point it out what's wrong with your code and all that. Okay. Okay. So with that, so let's move on. So we're going to look at a few things today. It's okay. So the first thing I want to talk is object-oriented programming. Okay. So you have something called a class. Okay. A class is a group of elements together. So I can have an employee class, and the employee can have a name, employee can have an age, salary, and all that. Okay, so for now, I'm just going to say pass. Okay. So what I'm doing here is 2 things. One, I declared an empty class. Whenever you see this statement called pass, pass means that I don't have any code right now. I'm just telling the Python that I will come back and add later. So for now, just ignore it. Don't throw an error because it's an empty class. Pass means I know that this class is not declared. So just assume that it's okay for now. Okay. So I just put pass there. That means it's an empty class. Class is nothing but a group of elements. I don't have any elements right now. So I just have pass there. Okay. And you see this line here, line 4, if __ name equal to main. Okay. So there are 2 ways you can run the Python code. As we saw before, so we had a square function. Okay. So you can see that we had a square function and we also had a cube function. Okay. So these 2 are inside a file called test_tutorial. Okay. And I have another file which is call_square. Okay. So if I click on that, so you can see that here I'm actually importing those 2 methods, square and cube. Okay. Now, if I go back to the previous file where there is a square and cube, here I can call this square of 5, okay, or cube of 5. Okay. So what's going to happen here is it's going to print. So print cube of 5. Okay. So in Python, I can put this code. I can say print square of 5, cube of 5. Okay. But if I want to get this into a different file, now I have a different file which has these things from test tutorial import square, cube, and all that. Or I can also have the first line, which is import So the first line is pretty much saying import test tutorial. That means the whole file is going to be imported into this file. Okay. Now, since I already have certain statements here, which is print and square, print of square and cube, when I import into the other file, it's going to run those statements. It's also going to print those things. Okay. So here I have print and square of 5, print square of 5 and cube of 5. In the other file also have the same thing. So it's going to be executed twice. Twice means 2 times it's going to print the same statements. Okay, so if I can just run this and show you. Okay, square is not defined. Okay, so let me just do this. I'm going to uncomment the above lines. Okay, so I have a square function that is defined inside the test underscore tutorial file. So I have to say test underscore tutorial dot square. Okay, same thing for cube, test underscore tutorial dot cube. Okay, so since I imported with that name, I have to call with the prefix. Okay, so if I run this now, so you can see that it printed 2 times. Okay, so one because I have the print statements here. Okay, and another one because I have the print statements here also. Okay. So if I don't want it to print twice, what I can do is I can put this if underscore name. Okay, so what this line here does, okay, so let me run this and show you what the output will be. So you can see that it's only printed once. Okay, now let me go back and explain to you what it did. Okay, so here I'm importing the whole file. Okay, and if you go back here, when it imports the whole file, and I'm saying underscore name. Okay, so this name will be the name of the file. Okay, or in the sense name of the module. Since I'm importing this into another file, this will not be the main file. Okay, so this file itself won't be the main file. Since I'm importing it to the other file, this will be the main file. Okay, so that if condition will not be executed. Okay, so anytime you want to put some code, yeah, maybe I'm too confusing you guys. If anytime I want to put some code into this file and execute as a standalone, that means if I just want to run this test underscore tutorial and run this anything I put here will be executed. Okay, so if I run this test underscore tutorial file, you will see that anything I put here will be executed. But if I go to the other, if I import it and if I call that, if I import that file, that will not be executed. Okay. Sorry, I have to run this file call square. Okay, so that won't be executed. So in a nutshell, if you just want this file to be executed, you would put all these statements here. If underscore name equal to main, do this. But if you don't want this code to be executed, when somebody imports this file, this is how you do it. Okay. So when I import this file into another file, this block of code will not be executed. Okay. So that is the whole point of having this underscore name equal to main. Okay. Hopefully it's clear. If not, then probably I can. Yeah, if it's not clear, let me know. Okay. Anyways, so moving on. Okay. So here, what I did is the same thing. If this file is being run as a main file, that means this file is not imported into another module, then execute this piece of code. Okay. But if this file is being imported into somewhere else, this will not be executed. Okay. So that is the whole point of having this name equal to main. Okay. If this is a main file, execute. If this is not a main file, don't do anything. Don't do anything that's inside this block. Okay. All right. So if I run this now, It will not print anything. It's just blank because I don't have any print statements. Okay. All right, so I have an employee class here. What I'm going to do is every class has something called a constructor and a destructor. Okay, so we'll look at the constructor first, which is the initialization part. And then we also have something called a destructor. Okay, so whenever I create this object and line 9, that will initialize, that will call this initialization method. Okay, and when Python sees that on line 10, there is nothing, we don't use E, we are exiting the program, it knows that it doesn't need E. Okay, so it goes and deletes that method, deletes that object. But the way it deletes is it calls this del method, which is delete method. Okay, so if I execute this piece of code here, okay, so first we are initializing the object and then we are deleting the object. Okay, okay, now why do we care about initialization or deletion if it's automatically calling that? Okay, so we do want to care that because I might have an employee with a name, age, and a salary. Okay, so I might have somebody by name Sam. His age might be 20 and his salary might be $1,000. Okay, so if I have that, then this initialization method should require 3 parameters. Okay, forget about self for now. I'm going to come back and talk what self means, but for now, just ignore it. So you have a name, age, and salary. Okay. Okay. So here I'm getting 3 parameters. Every employee class, when we are initializing that method, we are initializing with a name, age, and salary. Okay. Now, when I print this, no change in behavior. We are just taking 3 parameters and we are not doing anything, which is fine. Okay. Now I want to store this. That means, let's say if somebody says something like, can you print this particular employee information? Guess what happens? Okay, so it prints the address of the object. Okay, so this employee object is in the memory somewhere. It's in the system memory, which is a heap memory and all that. And that memory has an address. Address in the sense, yeah. So that is how Python references, goes to that memory, accesses that object, and so on. Okay. So when I print that employee class, it actually prints the address of the object. Okay, so it just says employee object is at this address. Okay, this is not useful for us. It doesn't say anything. Who is the employee? What is the salary and age and all that? Okay, if I want to have print some meaningful information. Okay, so we can write a method called underscore underscore str underscore underscore. Okay, so this I can say print. Okay, so I can say print this is an employee class. Okay, so I'm going to come back and talk more about that. Oh, sorry, not print, return. Okay, so whenever I say I write this underscore underscore str underscore underscore, that means this will be called anytime you call the print statement. Okay, see, now you don't see an address. It prints something saying this is an employee class. Okay, the address is gone. We don't have the address anymore. So what it is doing here is whenever you call print, and it knows that E is an employee, and it also knows that employee has something, a string method. Okay, so it knows how to convert that employee class to a string. So it calls this method, it gets a string, which is this string, and it prints that string. Okay, this is an employee class. Okay, now let's extend this a little further. Now let's get back to self. Okay, self means the same instance. Okay, that means I can have another employee, E2 employee, Bob. His age is 30. Let's say his salary is 1200. Okay. Okay. So also want to print E2. Now here, okay, if I run this, okay, so we are initializing two objects, okay, because I have E1. Let me call it E1. Okay. So I have E1 that is initialized, E2 which is also initialized, and then I'm printing those two. So you will see this this an employee class, this an employee class, and Python knows that it's not used anymore, so it goes and deletes those objects. Okay. Now here is an interesting thing. What happens? I mean, this self here refers to the same itself. Okay, it's like itself. Okay, that means if you access Sam's name through E1, it will only self will refer to Sam. Okay, so if I do this, okay, self dot name. Let me change this down. Call it. So so here what's happening is self refers to itself. Okay, and when I assign the name to n, this name is pretty much referencing to itself. Okay, so here also I'm going to change a little bit. This is an employee class for, or I can say, okay, that's fine. Okay, so you can see that. So whenever I assign to self, and I also have the self in other methods, other functions also. Okay, so I can access whatever I assigned in the initializer or in any function, I can access from another function. Okay, that means this whole employee class, this self is a pivot. A pivot in the sense it is across all the methods. Anything I modify here for self, I can access here. So it's a self instance variable. Okay, so self is called instance variable for itself. Okay, so here when I access self.name, whatever the initialization has done, it will access those and it will print it. Okay, so I can even make it more better. Okay, now you can see that now it makes a little more clear. Okay, so you have Sam's salary as 1000 and age is 20. Okay, Bob's salary is 1200 and age is 30. Okay, so what we did here is we have an instance variable and we assigned to that instance variable all these different state, name, age, salary, which was passed to the initialization method. And in the print method, we are printing those which are pretty much the self itself refers to itself. So I'm accessing those, printing it out. And the print is pretty much, I'm going to display it out kind of stuff. But yeah, so this is a instance variable and these are all member methods. Okay. So a class is also called an object. Here it's an employee object. And these are all members because you can access using an employee class. Okay. All right. Now let's do something else here. Okay. So let's say Let's say you wanna, okay. So instead of age, I'm gonna say date of birth, okay? Or let's say for simplicity, I'm gonna say date of year, of birth year. Year equal to, got it. All right, now here I'm gonna say, let's say this guy is 2000 born and the year is 1990, right? Okay, all right. Now I want to have a method called getAge. So in an employee database or in somewhere, I have the date of birth of the employee. I don't have the age of the employee. Okay, so it's just that whenever an employee joins the company, we store their date of birth. And there's a method which is called getAge. What the getAge does is it computes the age of that employee and will give you that value. Okay. So for simplicity, I'm just going to do this. Yeah, this computation may look a little. So what I'm going to do here is this. I'm going to copy this. Okay, by the way, so in PyCharm, the bottom you can see there is something called a Python console. So if you click on that, it will open up a Python console and you can experiment with some code. Okay, so I'm going to say import date time there. Okay, module data has no string parse time. Okay. Oh, okay. Okay. Okay, perfect. Okay, all right. Okay, so don't worry about this calculation right now. So what I'm doing here is it gives the age of the employee. Okay, so you can see at the bottom here. I'm not sure if you can see. It shows the age as 11,422. I'm just going to print this and show you guys. Okay. Okay. So So there are a couple of things I did here. Okay, forget about this calculation here, but I added a method called getAge. Okay, so what getAge does is it does some calculation and it will return the age of that employee based on the birth year. Okay, so here I passed when I created the object Sam, I said Sam was born in 2000 and Bob is born in 1990. Okay, and then I printed those two employees. So you can see that. Sorry. So you can see that it prints the employee information, and then I say, give me the age of E1, which is Sam. Okay, so that prints out this. Okay, it says 7,770 days. Okay, so you guys can probably open up a calculator and compute that. But yeah, it's supposed to print even more nice in a nice format, saying 20 years, whatever, 10 months or 3 months and all that kind of stuff. Okay, so I haven't formatted this properly right now, but we can format it. I don't want to go into calculation of the date time. So for now, assume that it prints in a nice way, which is like 20 years, 3 months, and all that kind of stuff. Okay. So getAge is a method that is provided for an employee class. And if I want to call that method, I just do this E1, which is the employee class dot getAge. Okay. So that means it will call this getAge method of Sam. It will not call for Bob. Okay. Because E1 is of Sam's method. Okay. So it will call Sam's corresponding instance or a self variable. Okay. And you also notice that the getAge method has no parameter. Here I'm accepting one parameter, which is a self variable. Okay. And here there's nothing there. That means anything you do even dot getAge, internally what Python does is says get underscore age for E1. Okay. So internally what it does is it calls the getAge for E1. E1 means pretty much this object, which is Sam's object, and it will access those variables. Okay. So this in a nutshell, what a class means, and these are the member methods. And now you can see you can add even more methods. Okay. You can also have a joining date. Okay. So joining date equal to JD. And you can even provide a joining date. Let's say this guy joined in very recently, 2020. Okay? And let's say this guy joined maybe 3 years back. Okay, so 2018 and all that. So okay, so maybe we'll say he joined 10 years back, 2010. Okay, so let's say that the company says all the employees who are here for more than 10 years, we want to give them extra holiday, or maybe they want to send them some coupons or something. Okay, so they want to make those employees who are here for a long time happy. Okay, so they might have this function which says is valid, or let's say the company wants to give them some bonus. Okay, so is bonus applicable? Okay, now you're going to do some certain calculations and you're going to finally return true or false. Now the calculation can be based on the joining date. Okay, so you have a joining date, which means that you look at the joining date. If he's here for more than 10 years, then you say yes, he's eligible for that bonus. He's not eligible for bonus based on that. Okay, and then you might have some other calculations. E1 dot is applicable, is bonus applicable. Then maybe you might say deposit some money into the bank account or whatever. Okay, so you might have all these kind of functions there. Okay, but you get the gist of the class. Class will group all the things together. Okay, that means it can have member methods, it can have member variables. These are all variables. Okay, it can have member variables, member methods. You can even override some of the standard methods. So anything you see underscore underscore at the beginning and underscore underscore at the end are standard inbuilt functions. Okay, so when I say print, I'm not calling this string method. Internally, it will automatically call that. Okay, so that's an inbuilt function that I'm overriding. Okay, so built function that we are overriding. You might be thinking, what is overriding, right? Overriding means initially it was printing the memory address. I'm overriding that to say, don't print the memory address, but print something else. Okay, so this is what we are printing. So that is overriding pretty much. Okay, there is some implementation, but we don't want that common implementation. I want my own implementation. That is overriding. Okay. Okay. Any questions so far? Okay. Now you might be thinking, what's the use of all this, right? So let's go back to unit testing. Okay. So I'm going to comment all this. So Python has a module called a unit test. Okay. So what that module does is it provides certain things. So if I go back to test_eBay, so here I'm saying that if look for this text in the response.txt. Okay. If it is there, then print this. If it is not there, sorry. If it is not there, then print that web page title is not working as expected and all that. Okay. Same thing for sign in. Now, this is not a good method of testing. I mean, who is going to look at print statements? Let's say there are thousands of these statements. Who is going to go through every one of those and say, hey, did it get printed? Did it not get printed, and so on? So nobody's going to look at the print statements. Uh, Everybody wants to look at how many test cases have passed, how many test cases have failed. Okay. So here I have no information. I have two test cases here. One of them is verifying the title. The other one is verifying the sign-in option, right? So there is nothing to say whether both of them succeeded or failed. Okay. So Python's unit test framework can help us with that. Okay. So I'm going to have a class which is going to be test eBay. Okay. So I have a class called test eBay. Okay. There should be test suite or test okay, test case. Test suite or test case. I'm going to go with test case one. I have to look it up, but let's try it out. Okay. And then I'm going to have def init. Okay. Init method is the initialization method. And what do we do? Do inside the initialization method? Is we want to load the page because this is happening only once. Okay. So I'm going to have this inside the initialization method. Okay, so it's complaining that the requests, it doesn't know requests. So I'm going to put this import. Okay. Okay, now it's happy. All right, so now I'm going to say, instead of just putting a response, I'm going to say self.response. Okay. So this, what it's going to do is when I'm creating a new object, it's automatically going to initialize this object. As soon as it's initialized, I'm going to eBay page and I'm getting that page. Okay. Now I'm going to have a test case, test title. Okay. And the same code that I had before, I'm going to put it here. Okay. But this time I'm going to change a little bit of code. So I'm going to go with one test case for now, and then I'll add the other one. Okay. Or let me add that also. Yeah. So what I did here is I have a class called test eBay. Okay. By the way, a class can be anything. It can be an employee class, or it can be anything that you want to define it. It can be something about the elevator also. You have an elevator class. People are pressing the buttons on the elevator. It has to go to 10th floor, 5th floor. So you might have a class which is an elevator class. You might have press button. You might have open the door function, or you might have emergency or whatever. So you can have that class there, which can be any class that you can define, where you can group all of these methods together. Okay. So here I have a test eBay class, and this what you see inside, that means this test eBay is a unit test. Okay. That means pretty much this class is of type a unit test class. Okay. And then I'm going to have this. So here, pretty much we are saying, if you run this file by itself, do this. Okay. What I'm doing here is if I run this file by itself, run this unittest.main. Okay. So let me run this, and I'm going to show you what happens, and then we're going to talk more about it. Hold on, there's one question, but look at all this. Okay, correct. It says ran 0 tests. Interesting. Okay, fine. Hey, give me 1 second. Let me just search for it. Okay, it's a test case actually. Okay, so I'm going to make it a test case. Oh, yeah. Sorry. By the way, when you have this unit test case, I should not have an init. Similar to init, there is something called a setup. Okay, so I should be calling that setup. By the way, sorry about that. Okay, now it should work fine. Okay, so I should say self.response. False. Assert true. Oh, sorry, it should be in that. That text has to be in the file. So, okay, describing more about it, right? So initially we saw there's an init method. If I scroll up, okay, so you see the init method where we are doing the initialization. Whenever a class is derived or it's of type unit test class, this setup is similar to the init, but you have to call it a setup. Okay, setup means that is the one-time initialization setup that it does. So that's why it's called setup. Okay, it's similar to init, but you cannot call. I mean, you can call init, but setup is the one that is the right method to call. Okay, and inside that setup or initialization, what I'm doing is I'm loading the web page only once. I don't want to load that page every time I want to run a test case. Okay, I'm loading only once. I'm getting the response, and anything you see test underscore, anything starting with test underscore is a test case. Okay, so if I have another method which is def add, okay, pause, it's not doing anything. So this won't be a test case, okay, because it doesn't start with test underscore. Anything starting with test underscore is a test case. Okay. Now inside the test case, what I'm doing is assert true. Okay. When it sees assert true, that means the output of the statement should be true, okay, or the result of this statement has to be true. That means pretty much this text has to be in this response. If the text is not in the response, this will be false, okay? So this will be false if this text is not in there. So assert pretty much means that it's expecting this condition to be true. If you want assert to be false, that means you don't expect certain things. You can also say self.assert false, okay? So you can say 1 not equal to 2. That is false, which is right, okay? Or you can say self.assert equal 1 comma 1. Okay, you expect 1 to be equal to 1, so you say assert equal. You can also say assert is also almost equal. Almost equal means you divide 1 by 3 and you want to say these two are almost equal, okay? That means if you divide 1 by 3, you will get 0.33 for so many digits, right? So you don't want to go crazy on that, so you just say almost equal, okay? So that means it's going to compare those two and it's going to give you the value which is almost equal, okay? And then you also have other asserts, okay? There is assert count equal, dict equal, and so on. So let's not go into all of them. Okay, so assert pretty much what it means is that you are expecting certain thing to happen. If it is true, everything is good. If it doesn't happen what it's expecting, that means the test case fails, okay? That means this test case will fail. So let me run this first. Okay, 1 not equal to true. True is not false. So sorry, this is true actually. 1 not equal to true is true. I'll make this false. 1 equal to true. 1 equal to 2, sorry. Okay, so you can see that everything succeeded fine because I'm expecting this condition to be false and I got a false back, which is good. And here I'm expecting both of these to be true equal and I got an equal, which is good. Okay, assert true. 1 not equal to 2. Okay, so I expect this condition to be true, and if I get a true back, that means this is okay. But for whatever reason I don't get this to be true, then it's the whole test case fails. Okay, so I'm going to run this and show you. Okay, and also you can see there are 2 dots here. 2 dots represent 2 test cases. So the first one ran, it prints a dot. Second one runs, it prints another dot here. Okay, that's not important, but yeah, those 2 dots is what it means. It ran 2 test cases. So if there are hundreds of test cases, you can see the dots progressing. Like it will print 1 dot, second, third, and so on. So you can see there is some progress that is happening there. Okay. Okay. So here assert means that you expect something to happen, and if it happens, that's good. If it doesn't happen, then it fails the test case. Okay. So here I'm going to say 1 equal to 2. Okay. So I'm saying 1 equal to 2, but that's a false. But I'm expecting to be true. That means that's going to fail the test case. Okay. So I'm going to run this and show it to you. Okay. So you can see that it prints a bunch of trays first, okay, and it also shows at the very bottom saying it ran 2 tests and it took less than 1 second. You can see it took 0.9 seconds, and out of the 2, failures equal to 1. That means 1 test case failed. Okay, that it doesn't show how many succeeded. It just says it ran 2, and out of the 2, 1 of them failed. Okay. And you can also see that it prints what is the failure, why did it fail. Okay, so it says it prints a statement saying assert true, assert 1 equal to true. That means you are expecting 1 equal to 2, but that's not true. So it says false is not true. That means it's expecting something but it got something else, so it's pretty much failing there. Okay, so I'm going to remove this for now or comment it out. Yeah, so here what I'm doing is I'm expecting this text to be in the response. Okay, and if the text is not there, then I can see that the title test failed. Okay, so let's say I expect electronic instead of electronics. Okay, I run this. Okay, so it says, hey, you're expecting this to be in the response.text, but you don't see, so it's a failure. Okay, failed, failure is equal to 1. And it also prints the test case name. Test underscore title is the one that failed. So if somebody is running this unit test, let's say there are hundreds of test cases, it's very clear for them what are the failures, what are the things succeeded and all that. Okay. Any questions so far? Okay. All right. So here you can see there's a setup, right? Setup means it's going to run one time. And similar to the delete method, there is something called a tear down. Okay. That's okay. So setup is called when it is running first time or when it's constructing itself. Okay. Tear down is called in the very end, similar to the delete method that we saw before. Okay. So I can. So in this case, we are just getting the web page. Since we got the web page, there is nothing to do. But let's say you open up a file. You want to close the file, right? So let's say you're opening a file here. So you can say self.file equal to open. Let's say I open this names2.txt file or some file. Okay. Okay. So here, what we did is we opened up a file. I may do something with the file in the test cases. Okay. So once I'm done with the test cases, I want to close the file, right? So I put that in the tear down. Okay. So normally anything you do inside the setup, you try to clean it up in the tear down. So let's say you open up a database connection. You want to close the connection, right? So you open up in setup, you close in the tear down. Or you might open up a file, you might close a file in the tear down. So any resources that you allocate is done in the setup, and all the cleanup is done in the tear down. Okay. 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 So this at a high level, what the unit test module does. Okay. Now we also have written a method which is this is square and cube, right? We have written these two methods, square and cube. Let's say I want to test these methods. Okay. A simple use case. So I'm going to add that, and I will have more test cases here. Okay. So I have a test method just testing the square. Okay. So I can say self.assert equal. So I'm going to use the equal method here. I expect the square of 5. So for some reason I'm choosing 5. I'm going to choose 10. Okay. Okay. So sorry, this should be test underscore tutorial. Okay. All right. So what I'm doing here is I'm calling this method, which is test square 10, and the return value of that square method should match with 100. Okay. So I'm saying make sure that the return value of square 10 is 100. Assert equal will make sure it's equal. If it's not equal, this test case will fail. Okay. So let me run this, and okay. So you can see that it ran 3 tests, everything successfully. Okay. Now I'm going to go back to test tutorial and I'm going to put a bug there. Okay, bug in the sense. Okay, so somebody implemented the square function incorrectly. Okay, so instead of returning 2 times, they're also adding 1 to the number, to the total number. Okay, so this, put this. Okay, so I'm going to go back here. Sorry, here, and I'm going to run this. Okay, now you can see that first at the bottom it says ran 3 tests and it failed 1. Okay, now out of the 3 tests, what failed? If I scroll up, I can see test underscore square is a method that failed. And why did it fail? Because you're expecting square of 10 to be 100, but you got 101. 101 is not equal to 100. So here I said assert equal, right? So it will try to make sure that both of them match, but it didn't match. It's going to throw an error, or in the sense the test case will fail. So it's a very simple test case. So you can catch different kind of things with the asserts. Okay. Same thing. I can have another method for cube also. Cube of 10 to be 1000. Okay. So you can add even more. I can even say self.assert equal test underscore tutorial dot cube of 1 should be 1. Okay. Or I can say self.assert equal test tutorial dot cube of -1 should be -1. Okay. So you can add more and more test cases, the ones that you feel appropriate. Okay. You can have something like a 0. Okay. What is the cube of 0? Okay. You can add as much as you want. You can even put inside a for loop. Okay. So I can even say for I in range, I want to go from 0 to 1000. Okay. And I want to say self.assert equal. I mean, this is a hypothetical example, but you can do anything you want. Okay. So it's pretty much that you are saying for this cube, it has to always match. It has to always match this result. Okay. This can be anything. You can even go to your database, get the value, and you can compare what the function is giving you, what the database is giving you. Okay. Or you can also, let's say you opened up ebay.com, you signed in, you have a name. So you go to the database, you verify what is the name of that user. You also verify what is the name on the web page. So when you compare 2 names, yeah, they have to be equal, right? So what is in the database should be the same as what is shown on the web page. So you can use assert equal for that. So if I run this, it should work fine. Oh, it failed actually. Oh, sorry, 101. I didn't fix that. Okay. Yeah, it actually 2 failures. 0 not equal to -1. Oh, sorry. For 0, it should be 0. Okay. So there is another module that will generate a HTML page. Okay. So that I don't have that module installed. Yeah. So I'll also show you another module right now. But what it does is, let's say there are hundreds of test cases. Okay. And you're running this on a remote machine. You're not running on your local laptop or desktop. You're running on a server, and it runs through all the test cases, and it will generate saying that I ran 200 test cases. Out of the 200, maybe 6 of them failed. Okay, so you want to go and see which of the 6 test cases failed. So it's very difficult to go through all the text in here, because there might be other text. Somebody might print here. Somebody might put something like running for 0. Okay, somebody might put running for negative numbers. So people like to put some print statements and all that so that they know what is going on. But when you look at the final report, it will be thousands of lines. Out of the 1,000 lines, you want to find out where is the assert, what is the assert that failed. That becomes a little cumbersome. So there is a tool that can generate a HTML page out of the Python unit test. Okay, so what the tool does is it will look for all the different asserts, and finally it generates a beautiful report saying this test sign in, this is the result, which is success. Test square, success. Test cube, failure, in a red color. Okay, the rest of the success ones will be blue color. The failed ones will be red color. You can expand it and it will show you what is the assert that failed. It's more descriptive. Okay, so we will look at one of those tools right now. So any questions so far, by the way? Okay, cool. So there is another tool which is called Pytest. Okay, so what we used so far is a Python's inbuilt unit test. I did not install anything. This unit test comes with the Python module, with a standard Python installation. Okay, so there is another third-party tool which is called Pytest, and we're going to install it right now. So if you go to settings and click on this small plus arrow, plus symbol, and search for Pytest. Okay, so you're going to see something like Pytest. Okay, and click on install. So one more time, if you go to file and settings, you're going to search for project interpreter, or in some cases it will be Python interpreter. Okay, for some latest installations it's Python interpreter. So click on that and click on the plus and search for Pytest. Okay, and in the bottom you're going to see the install package. Just install the Pytest. You don't need these additional modules. Okay, and once it's installed, you can close all that. Okay, so let's create a new file. So I'm going to get rid of some of these. Okay, so this is what I copied from the other module, which is what we had before. I got rid of ebay.com, all those test cases. I just have square and cube. Okay, and I have the unit test module here. Okay, so I'm going to replace that unit test module with the Pytest module. Okay, and okay. So what the Pytest guys did is they wanted everyone to use Pytest. Okay, so they took the interface from UnitTest. Whatever you have the UnitTest, it will work for the Pytest also. You don't have to make any code change. You just replace UnitTest with Pytest, or even in some cases, there are other ways. You don't even have to replace that. But the code-wise, everything is going to be same. Pytest has more features than UnitTest. Whatever UnitTest has, Pytest already supports those, and it also supports additional things. Okay, so these guys, what they did is pretty much UnitTest. They took the UnitTest and added more features on top of it. Okay, so for this, what I did is I just instead of UnitTest, now I said Pytest, and I changed this test case, and in the main, I'm just saying Pytest.main. Okay, so if I run this guy, okay, give me 1 second. Okay, I guess you still have to use the unit test, but let me just verify. Oh, yeah, okay. So let's go back to unit test. Let's leave it at unit test. Okay. Okay. But when we run this, we run with Pytest. Okay. Okay, so I'm going to leave it there. And so I'm going to right click and say edit configuration. It's not here. Okay. So when you go to run option, you're going to see an option which is edit configurations. Okay. So when you click on edit configurations, you will see the Pytest tutorial, whatever the file that you ran before, and there's a parameters here. Okay. Okay. So put the interpreter options as -m Pytest. Okay. So when you say -m, you are pretty much saying, hey Python, run this with a module called Pytest. Okay. So I'm not sure if it runs. Let me run this first actually before I tell you guys to modify. Okay. Perfect. Okay. So what it did is it ran Python with Pytest and all that. Okay. Okay. Good. Okay. Fine. We'll come back to that. Okay. So here, yeah, so we didn't change any code, the same as unit test, okay? But what we did is we went to edit configurations, and in the interpreter options, I said -m Pytest, okay? Hopefully you guys have this option. If you don't see it or if you have an issue, let me know. But you need to have Pytest installed there. Do you guys see this option? And just you can even, instead of writing a test square and all that, you can say assert 1, 1, okay? Both of them have to be equal, right? So you can even put that statement there. Okay. Okay. All right. So So this is pretty much the unit test cases that we had before. I added more for square, asserts for square, okay? All right, so we are saying square of 10 is 100, 1 is 1, 0 is 0, and negative 1 is 1, okay? So when I run through this, pretty much the same thing as what we saw before. Format has changed a little bit in the sense you can see collected 2 items, and it says 2 passed in 0.31 seconds, okay? So pretty much same as what we saw last time. Format is a little different, but here is the power of Pytest, okay? So here, what I'm doing is I have 4 test cases, but 4 of them are pretty equal or similar, right? I don't want to write 4 lines. I want to write only 1 line for this. So I can actually parameterize, okay? So I can say, okay, @parameter, okay? And the parameter is going to be number, and the number is going to be what? 10, 1, 0, minus 1. Okay, so I'm just going to say here, okay, sorry. Okay, so I'm going to go with, yeah, fine. 10, 100. Okay, give me 1 second. Parameterize, yep. It might seem a little confusing first, but instead of, as you can see that I commented these 3 lines here, I only have 1 line now, okay? So the 1 line says, I have a number and I have an expected output, okay? So what is a number? What is the expected output? So the test function itself has 2 parameters. Forget about self, but 2 parameters, which is a number and what is the expected output. So where are those 2 numbers coming from? It's coming from here, right? So for the 10 is the first parameter. That means 10 will be number, okay? And 100 is the second parameter, and that will be the expected output, okay? So instead of me writing 4 lines or 10 lines of code, I can write 1 line of code here, okay? And I can parameterize it. That means I can pass a bunch of parameters to the test case saying, okay, for 10, I expect the output to be 100. For 1, I expect to be 1, 0, 0, minus 1, 1, okay? And I pass a list of all these things. So if I run this, this thing won't require position argument. Give me 1 second. Oh, yeah. So first I have to pass this number, expected The thing is, I have it inside a class, and these guys don't have it inside a class, which is screwing it up because self is another parameter that they don't have it here. Okay, so none of the examples have self. So let me. Okay, so for now, what I can do is okay. So here might be something. Okay, so they're parameterizing the whole class itself, but that is not what we want. Screw this. All right, so what I'm going to do is I'm going to take this off for now. Okay, so I have simple functions, not inside a class, but outside a class. Okay. So the functionality should be the same. So now let's run this and see what happens. Crap. Still hard to get rid of self here. I'm going to comment a bunch of code right now, and I'll come back and change it later. Okay. Fine. Okay, so what is happening here is this. Okay, I have only one test case now, test underscore square. Okay, this is outside the class. It's no longer inside the class, but outside the class, a standalone test function. And it's accepting two parameters, which is a number and expected output. And here I have a Pytest decorator. So anything you see at the rate symbol is called decorator before a function name. Okay. So what the decorator does is it will modify this function. You don't have to modify the function, but the decorator is somehow will modify that function. You don't have to change anything. So this is somehow what it's doing is it's pretty much calling that function for all those values. 10, 100, 1, 1, 0, 0. So the first number 10 is going to be this number. Okay. The next number 100 is going to be the expected output and all that. Okay. So when it calls that function, what it does is it calls a test tutorial of that square for that number, and then it compares with the expected output. If it matches, if they're both of them are equal, it's good. If they don't match, this assert is going to fail. Okay. So here you can see, instead of me writing all these lines saying for 1 expect this, 0 expect this, and so on, I'm going to change these parameters here. Okay. So when I change the parameters, it automatically will run this code for all these tests. And you can see at the bottom also, it says collected 4 items. Okay. It's actually only one test case, but since I have 4 parameters, it's a 4 different test cases. So it's going to run 4 different test cases, and it says 4 of them are passed and everything. Okay. So let's say one of them fails. So let's say for 0, I expect the value to be 2. Okay. So this will fail. I just put 2 there so that to show you guys the error message. Okay. So you can see that it collected 4 items, the 4 parameters it has. So number equal to 0, expected output equal to 2. Okay, but what happened here is you got a 0 and the expected output is 2, so they didn't match. Okay, so it clearly shows you where it failed, why did it fail, and all that. Okay, so it even shows the line number, the code, what is the code behind the failure, and all that. Okay, so this is Pytest. One of the advantages of using Pytest. Let's say there are 20 lines that you want to replace with a single line, so you could do that. In the sense that there might be other things that you might do with those parameters. You might, in this case, it's only one line, but you might have something like an if condition, you might have a for loop, and all that, like 10 lines of code. So if you have 4 tests, you might have 4 times 10, you might have 40 lines of code. So instead of 40 lines of code, you can have only 10 lines of code, and then you can parameterize different values for that test case. Okay. Hopefully it's clear. Okay, so so this parameterize is one of the advantage of using Pytest. This was not there in the unit test. Now let's see what are the other advantages. Okay, so let's say I have another method, which is, let's say, cube. Okay, okay, okay. One thing I don't like about Pytest is that it doesn't support this nice assert equal, assert almost equal, and all that. Pytest simply doesn't know what that means. Okay, so I have to get rid of that. So Pytest only supports assert. That's one drawback of using Pytest. It doesn't have all those beautiful asserts. Assert almost equal is a very nice assert that is very useful. Okay, but anyways, so let's say I have this test cube. I also want to parameterize it. Okay, okay. So here you have 2 test cases. One is square, one is cube, and pretty much similar as what we saw for the square. The cube is also going to do the same thing, something similar. 10 for 10, it is expecting the output to be 1000. Okay, and same thing for 1, it's expecting 1. For 0, 0, for -1 also -1, and all that. Okay, so no change in behavior, pretty much same as what it was doing last time. And when I run this, it says collected 8 items, because 4 for square, 4 for a cube, and so on. And it shows out the total time and all that. Okay, now what I want to show you is this. Okay, so let's say that in this case, it can run in any order. That means it can run the square first, it can run the cube second, or it can choose to run cube first, square later. It doesn't matter. As long as it runs both the test cases, that is fine, right? Now let's say you have thousands of test cases or hundreds of test cases. Okay. Now what Pytest does, it doesn't run sequentially. It will run with multiple threads. Okay, it will run one test case in one thread and another test case in another thread. So to tell you what a thread means, you guys know what a CPU is, right? So in a CPU, you have multiple cores. You might have a 4-core CPU, 8-core CPU, and all that. Pretty much each core can have 2 threads or 1 thread, depending on what the architecture is. But you can do multiple things at the same time. You can open up a browser, you can watch a movie in one window, you can install something else in the other, and so on. So it will run in parallel because your CPU can do multiple things at the same time. Okay, so Pytest, what Pytest does is it leverages your CPU. So if you have multiple cores, it will run in parallel. It will run one test case in one thread, another test case in another thread. So all of them are running in parallel. So if you have 100 test cases, let's say 100 test cases, each test case is 1 second. It won't take 100 seconds. It will take 25 seconds because it's running 4 things in parallel. So within 25 seconds, it will be done. Okay. Now, since it's running in parallel, okay, so it's running test case 1, maybe it will run test case 10 first. It will run test case 12 later, and so on. So there is no order in what the test cases are running for. But let's say you want to run this test case first, and you want to run this test case later. Okay, so you want some order somewhere. That means this test case might be doing something that this test case needs. Okay, so you might have something like a global variable. Sorry, it's not global, but let's say DB connection. Okay, so I have DB connection there, and this test case is opening up the DB connection. Okay, and here I'm going to use the DB connection. Okay. So that means I have to run the test square first, and then I have to run the test cube later. Because if Pytest decides to run in parallel, it might run this guy first, and then it might run this guy later, right? So there is no order when you give it to Pytest. Why is the Pytest doing that? Because Pytest wants to finish the test cases sooner. It wants to save you time. So it's running multiple things in parallel. It doesn't know what is the dependency between the different test cases. Okay, so you can, if you want to have a certain order, you can say Pytest.priority. There is something called a priority depends. Okay. Yeah. So Google is your friend. So keep testing there. Okay. Mark order 2, mark order 1. Okay. Well, I'm going to comment this code that I had, which is a DB connection. That was just to give you some clarity on that, why we need that in a certain order. Okay. So here what we did is I'm saying that, hey, Pytest, when you decide to run multiple things in parallel, make sure you run this first and then you run this second. Okay. Because if this guy runs first, it will try to use the database connection. It will try to access, but the database connection will be none. So it will fail. Okay. So you want certain order when the test cases are executing. Okay. Or I mean, if both of them can run in parallel, you don't need to put that. So if I run this now, okay, the title, I can register custom. Crazy. Okay. Choose this. Okay, so it says here clearly import Pytest and use this. That is exactly what we did, and it didn't work. Okay, so this Python 2.7.5 is crazy. We don't have Python 2.7. Okay. Okay, so this might be better. Okay, so let's try this. Order equal to and so on. Okay. Crap. Okay. Oh no, actually, you know what? It actually ran successfully. Okay, so it collected 8 items and it ran 8 of those test cases, and it says 8 of them passed, but there are 2 warnings. The warning is something different, which is so it's unable to find this run at all. Okay, so let me just click on this warning and try to see. Okay, fine. Ignore this for now. Okay. So something wrong. Yeah, I have to research on that, but that's fine. So this is one of the way that you can tell the Pytest run multiple things in parallel. But when you run, make sure maybe these 2 test cases are dependent on each other. Okay. So you can say run this first, run that second, or so on. Okay. But if there is no dependency, if this guy is independent from the other guy, you don't need that. So yeah, if both of them are independent, you don't even need to put anything there. And for square and cube, they are independent. I don't need to have that. Yeah, but if there is any dependency, you need to have that order, and Pytest can provide that feature. Okay. All right. Any questions so far? Okay. Now we are going to go talk about something another module. So this is Pytest. We saw UnitTest. Okay. So we saw what a class is, what are the member methods, initializer, destructors, constructors, different kind of asserts. We saw what is a Pytest and how to parameterize the test cases and how to run them in an order if you want to. Okay. So these are all the things that we saw. Now there is another module which is Selenium. Okay. So if I so last time we took an example of ebay.com, right? So okay, so I have this website, ebay.com, and what we did last time is actually, I would say, we tested the backend. Okay, so if I go back to here, so what we did is we said go and fetch the web page request.get ebay.com. Okay, that means we are sending a request to the server behind the scenes, the backend, and we are saying getting the page, and then we are validating the page. Okay, but what if the page doesn't load properly on Firefox, but it loads properly on Chrome? Okay, so you might have seen some web pages, they don't work properly on Internet Explorer or Microsoft products. It may work properly on Chrome or something vice versa. It may not work properly on Chrome, it may work on Firefox and all that kind of stuff. Okay, so when you do this, when you do request.get, you don't know whether the page is loaded properly or not, right? So we have another framework which is Selenium. All right, so what Selenium does, sorry, yeah, so what Selenium does is anything I can do as a user, I can click on this search box and I can put some text there. Okay, so I can say Samsung, right? I'm typing that SAMSUNG, and I'm going to the search text button there, and I'm pressing that button. Okay, so all these things Selenium can do. That means it can open up a browser, it can find this text box, it can put that text in the text box, it can go press the button called search, it will get the next page, and it can look up the elements and all that. Okay, but before we can use Selenium, we have to import that particular package. So let's go to settings, choose project interpreter or Python interpreter, click the plus sign, load something called Selenium. install that package. Okay, so that is installed. Okay, now let me open a new file. Okay. So are you guys able to install? Any questions on the installation? So this Selenium here, so I can do import Selenium WebDriver. Okay. Okay. So there is something called a WebDriver. Okay. So inside Selenium package, there's a WebDriver. What the WebDriver does is it can open up a browser, it can launch a browser, it can interact with the browser. Okay, so we're gonna show you a simple example here. Yeah, but before we do that, we also need to install something else, which is this. So open up your browser. Okay, so if you have a Chrome, open your Chrome. Okay, and go to the three dots in the very end. Click on those three dots, and you're gonna see something is something about help. Okay, and in the help there is about Google Chrome. Okay, so click on that. It will show you the version number. It says right now 89.0. Okay, so find that version number, and then we have to do this WebDriver for Chrome download. Okay, so search for WebDriver Chrome download. If you are using Firefox, you can also search for WebDriver Firefox download. If you have Microsoft Edge, you can look for Microsoft Edge also. Okay? So if it's WebDriver. So every browser provides this WebDriver. Okay, so they know that people are going to test different products using Selenium. So all the major browsers, Microsoft or Firefox, Selenium, Opera, Safari, they all provide a WebDriver. Okay, so we need the WebDriver to open up the browser. Okay, so I'm going to choose Chrome, but it's the same for other browsers also. Okay, so if you search your Google Chrome version, it shows up for me as 89.0. Okay, for you it might be different. So go to downloads for the Chrome driver. In my case, it's going to be this driver, which is 89.0. Okay, in your case, it might be something else. Okay, so just make sure you download the appropriate version. So click on that, and that will show up this. In my case, it's a Windows machine. So I'm going to click on Windows, but if you're a Mac, you can click on one of these. I guess Mac, this one. Okay. So for now, I'm going to put it in downloads folder. Okay. Okay. So it downloaded now. I'm going to go to extract it. Okay. I'm going to extract it to a different folder, which is documents or somewhere. Yeah, fine. I'm going to put it in documents. Okay. Okay, now I have this inside the documents folder, in this folder, Chrome driver, right? Yeah, there are a bunch of things we have to do. So you have to right click on the computer, Windows C drive, say properties. Actually, you know what? Yeah, fine. Give me 1 second. Okay, perfect. Actually, you can provide the whole thing also. Okay, fine. So yeah, that's fine. So I have this installed or extracted into this folder. Okay, C users, what are the name here and so on. So I'm gonna copy that. All right. So once you downloaded, install, extracted, and everything, so we're gonna go here, and I'm gonna show you a simple thing, which is equal to webdriver.chrome. You have to provide the path. So give it the whole path, including the file name. Okay, so I'm gonna go here. Let's see. .exe. Okay, and I'm gonna say c dot. It's not loading up. Okay. Right. Get. Okay. Okay. So what I'm doing here is, oh, by the way, are you guys able to download, extract all the files? There's another shortcut. Instead of putting it right here, you can actually put it in the path variable. But right now I took a shortcut. But yeah, that's fine. So what you do here is you install Selenium. But Selenium is a open source project, or in the sense it's a library. And every browser, Chrome, Edge, or Firefox, they have their own web drivers. Okay, so Selenium is not going to provide the web driver, because tomorrow there might be another browser, and Selenium doesn't want to own the ownership of those drivers. Okay, so every company releases their own web drivers, and every browser has different versions. Okay, every version is going to be different. So if you have Chrome 89 installed, you have to install the WebDriver for 89 and all that. Okay. So once you download, install everything. So do this from Selenium, import the WebDriver, and say browser equal to, open the Chrome browser, and you have to provide the Chrome driver executable. Okay. And then you say browser.get ebay.com. Okay. So if I run this code, I'm not going to do anything. You're going to see a browser that it opens up. Okay, so it says Unicode can't decode positions 2 to 3 truncated. I'm going to say U. Crap. Okay. Is it capital C? Yeah, capital C. Okay, let's try that. So Windows has backslash, Unix has forward slash, but looks like Selenium and so on. These guys used forward slash. Okay, so let's go with forward slash. Let's try that. Okay, so allow access. All right, so you can see that there's a Chrome that opened behind in the background, and it says this a small notification which says Chrome is being controlled by automated test software. You can see that. Okay, so I'm going to click on that browser, but pretty much what it did is, it opened up a Chrome browser, and it also shows this message. I'm not sure if you guys can see that Chrome is being controlled by this, and it opened up ebay.com. Okay, now what I did is pretty much what a user does. A user opens up a browser, goes to a website, right? The same exact thing, we did that with the Selenium. We opened up a browser, Chrome browser, and then we did this, which is go to this page. Okay. Now I can even do more things. I can even say, so I got a web page, right? Okay, so I got an eBay page. eBay.find, come on, why is the autocomplete not working? Okay. Okay, so I'm going to look for this element, which is search for anything. Okay, so I'm going to look for this search, which is this guy. So it might look a little challenging, but it's not challenging at all once you know what you're doing. So here, inspect this guy. Okay, here it is, input. So you can see on the, okay, so you can see on the right side. So what I did is I right clicked and I said inspect. Inspect pretty much looks up what is the element that has to be looked up and all that, and it finds in the web page, and it shows me the it highlights the page and it shows me that. Okay, so in this case it says that the class name is this. Okay, so I'm going to copy the class name, which is that, and I'm going to go here and I say find element by class name. Okay, okay. So what I did here is I found the search field. Okay, which is the class is this. Okay, there's a class name, there's a type, and there's a name also actually, underscore nkw. I'm going to go with name. Okay, find element by name. So you can see that here there is a name equal to underscore nkw. I'm not sure if you can see, but if you can look closer, you will see underscore name equal to, sorry, name equal to underscore nkw, right? So that's exactly what I did. Find element by name in the eBay page. Okay. So the very first thing I did is open the browser, and then I told the browser, go to ebay.com. It went to ebay.com. It got me a page, and in the page, I'm telling it, can you go find this element by name, and the name is underscore nkw. It found it. Once it finds it, I'm saying put the text Samsung there. Okay. So let's run this code. So I'm going to close this. Okay. So I'm running this. It opens up the browser. It loads ebay.com. It doesn't put in the search field. Maybe there's an error. Let's see. Yeah, there's an error here. Okay. Non-type as no element, find element by name. Okay, so let me see what is the error here. Oh, sorry, we just do driver dot find element. Okay. Oh, sorry. Yeah. Find element by name. Samsung. Okay, fine. So I ran this again. So it's running again. Can't set attribute text. Okay, so it's not text. Maybe it's input field or something like that. So let me just verify that. Send keys. Okay, send underscore keys. Okay, let's try that. So you don't need to remember all the functions, all the methods. You can look it up. As long as you have the idea what you're doing, that is all it matters. Okay, you don't have to remember all the details. You're not supposed to remember all the details. You can look it up and all that. You should just know how it works at a top level, high level. Okay, so you can see that it put a text called Samsung in there. Okay. Okay, so what we did here, I'm gonna go back here. Okay, so we open up a browser, Chrome. I have an eBay page. I'm trying to find an element, and in the search field, I'm putting this text called Samsung. Okay, so once I put the text field, I actually want to press the search button, right? So let me actually look for the inspect and try to see what is the name of the button, and then I can simulate a button press. Okay, so I'm gonna say inspect one more time. Okay, so the name of the button is, okay, so the button doesn't have a name, but it has an ID. Okay, so you can see the ID is this. I'm going to make it bigger. So the button ID is gh-btn. Okay, so I'm going to say here browser.find element by ID, and the ID is gh-button. Okay, so I have submit button equal to, and I'm going to say submit button click, or is it click or submit? Right, let's say just to click. Okay, if it fails, I can come back and fix it. Okay. All right, so let me run this again. Let me close all the browser windows first. It opened up the browser. It's loading up ebay.com. It's trying to find the element search Samsung. It put there, and it also pressed the button search. Okay, I didn't even touch this browser at all. Okay, so everything is controlled by the Python behind the scenes. This is pretty much what you can expect a user to do. Okay, so he opens up a browser, and he's trying to load some search, and then he's trying to press a button. Okay, so that is all testing. That's how you test, automate it. Okay, and there are many uses. I'm gonna probably talk in the next sessions, but so here I'm just opening up a Chrome browser, right? I can test it with a Firefox. I can test it with the Edge. So here I can say, um, yeah, uh, WebDriver.Firefox. Okay, and this Chrome or Firefox, I can have in a config file, or I can even pretty much say here, if input, or if you're reading from some file, you can test with Firefox, you can test with Chrome, and so on. Okay, so you can have some condition there saying, hey, do you want to test with Firefox? Okay, I'm going to run this, which is only the first line is going to change. Okay, only these two lines are going to change. The rest of the code is going to remain the same. Okay, so I'm just going to say if Okay, so if okay, so I'm going to do something like this. Okay, so I don't have the Firefox WebDriver installed, but if I have a Firefox WebDriver installed, I could do something like that. So I'm going to comment that for now. All right, so at a high level, what the WebDriver is letting us is automate that. So I can open up a browser, I can go to a web page, I can get the web page, I can find some elements by name. So here I'm finding the element by name, right? And I can also find element by ID. It's up to you how you want to find it. Okay, so here if I right click on this and I say inspect, I'm going to say inspect one more time. It went here. So in this case, I have a input type equal. Okay, let me copy this actually. Copy element. Okay. Okay, so this is the whole element. So when I right clicked on the search field and I said give me the element or inspect the element, this is what I got back. Okay, so you can see that there's a class name. Okay, so the class name, I can also do find element by class name. Okay, so I can do here find element by class name, and I can give it this class, which is this guy. Okay, so I can give it a class name also, or I can also say ID equal to GHAC, right? So you can also do find element by ID. Or if you have a name, you can also do find element by name. So there are many ways to find elements. You can choose any one you want. It depends on how they have developed the web page. Some people just put the name, some people put just the class name, or it might be ID or so on. So depending on what the web page has, then you should be able to find those elements. Yeah, that's a very good question. The question is, how do I find element by Xpath, right? Yeah. So you can also do by Xpath. So you can do something like browser find element by Xpath. Okay. So there's another function which is find element by Xpath. What it does is Xpath is a little different. Okay. So if I go here, you can see that there's a HTML on the top. Okay. And inside the HTML, there's a body. And inside the body, there is a division. And inside the division, there's a header. And inside the header, there's a table. And inside the table, there is all these members there. Okay. So if you want to find the X path, you can also provide that, saying under HTML, there's a body. Under body, there's a division. Under division, there is a table, body, and all that kind of stuff. Okay. I personally don't like XPath, but in some cases you have to use XPath. Let's say you have a table of 10 columns and all that. So you don't have a choice because you have 10 rows. The whole table is defined as a single ID or a single class name. So I cannot just say find element by ID because it gives me the whole table. I don't want the whole table. I just want the row 1, 0 column kind of stuff. In those kind of cases, you definitely want to use XPath. But Xpath pretty much here, let's say if I have to do the same thing in Xpath, I can do something like this. So this is under division, and inside division there's an input, right? So I will do something like div, or yeah, let's start with table, and inside table I have inside table I have table body, division, and all that. Okay, so I'm going to probably start with that table, and inside table I have t body. Okay, body slash division slash whatever you have. Okay, so you're going to put all that path, how to get to that element. So if I have this element, so I'm going to give it under this, under this, under this, go to that element. So that is how you're going to do XPath. XPath itself, I don't like XPath. If there's another option, I choose the other option, which is element by name, class name, ID, or so on. Okay. But as I said, in some cases, you don't have a choice, but you have to use XPath. But if you have to do XPath, then you have to provide the whole path or even the partial path, how to get there. Okay. So yeah, let me just comment it out. Okay, so here, as I said, so we are opening up a browser and finding elements and clicking and all that. So the thing is, it loads all these elements, which is good. Now, when I press the submit button, it went to the next page, right? So since it went to the next page, I want to see that the first result is a Samsung result, not some iPhone result or something. Okay, so I can also say, give me inspect this element. Okay, and I can get that element, I can get the text of that element, and pretty much try to see what is the text. The text here is Samsung Galaxy and all that, right? So I can find the element, and from the element I can get the text of the element, and then I can do assert. So similar to what we did before, assert search result dot text, or Samsung in that search result dot text. Okay, so here search result is the element that's in the next page after I press the submit button. Okay, fine. We'll look at it in the next class. I don't want to keep you guys waiting or holding. Yeah, but pretty much this is a web driver, and it's very useful in the sense if you're working in automation testing and so on, you need to know Selenium. And eBay uses a lot of Selenium actually. Yeah. Internally, I know some people who work in eBay, and they use Selenium WebDriver. Any questions so far? Okay, so what I'm going to do is I'm going to give you a small assignment. Please do the assignment and submit. Okay, so we'll pick a website. Last time we picked Amazon.com. Yeah, this time we're going to do something else, something very interesting, right? So I want you guys to go to mail.google.com. Okay, I'm going to close this actually. And I want you to press this create an account button. Okay, so when you create an account, it shows up this thing. Okay, and I want you to find the elements. Find the first name, last name, this username, password, confirm, and all that. Okay, so this is a selection box. You can say select equal to yes or some function. You can Google on that or whatever. Okay, it doesn't matter. But you're gonna find all these elements. You're gonna put those values, and you're gonna press the next button. Okay, so you are creating a Gmail or an email account on the fly. Okay, so actually people do use it. They actually test certain things. Is this coupon working? Is that coupon working? They can write a program that can automatically go to a website. It can put some automatic coupon there, try to test it if it's working good or not. But yeah, so what you can do is a simple use case. Go to this Google Gmail.com and try to create an account, put the values, press next button. Okay, so if I say, I'm just going to type something here. Okay. Okay, so stop here. You don't have to give the phone number, but just load this page. So if I go back, okay, so put some values in the first name, last name, username, password, confirm the password, and press the next button. Okay, so you know how to press a button, you know how to put a search in the text field, and just press the next button. Go to the next page. Make sure, give me one second. Okay, when you go to the next page, make sure the page shows this verify your phone number somewhere in the page. Okay, so that is all you need to do. Okay, install WebDriver for Chrome. Okay, open. Okay. Okay. Yep. So create an account. So when I say here click an account, click on create an account, I mean programmatically. Okay, not manually. So you need to find that button. You need to press that button and load the next page and enter all the fields. And press the next button. Okay. Number 6, load the next page and make sure it says enter your phone number. Okay. Very simple use case, exactly what we did in the class here. You need to install the WebDriver for Chrome, open that website, click on the button, enter a bunch of text fields, click on the button again, and you make sure that this text is there somewhere in the web page. Okay. Now, a bonus. Okay. Do the same thing for Firefox and Microsoft Edge. Okay. Your code doesn't change. Only the first line, which is a browser, is going to change. But in order for this to succeed, you need to have the Firefox driver, WebDriver, also the Microsoft WebDriver installed. So make sure you install it and you can run this. Okay. Okay, I just pasted it in the GoToMeeting chat window. Copy that because once I close the meeting, you may not be able to see that. Okay, guys, I think we are running close to the time. Actually, we ran over time. Any questions so far? So if you guys know this, which is UnitTest module, Pytest module, the Selenium WebDriver, you would know 60 or 70% of the testing, or even more actually. Even if you know, I would say, at a high level, you are pretty good actually, because a lot of people out there have no idea what is the Selenium WebDriver is, or maybe what a Pytest module or a UnitTest module is. Okay, so if you know these things, you are far ahead from other candidates out there. And even if you're a developer, you still need to write some test cases. Okay, so if you might develop some backend, but you might be asked to test your own code. Okay, so even if you're a developer, you may need to know about the test cases, how to write the test cases and all that. Okay, so it's not just for QA people, but even the developers have to know this. Okay, guys, if no questions, then I'm going to stop here, and you guys enjoy your weekend. Take care, guys. Bye.